In this video, we are going to evaluate a sum modified from a problem in JEE Advanced 2018. To evaluate 1 times 10 choose 1 whole squared plus 2 times 10 choose 2 whole squared plus 3 times 10 choose 3 whole squared, adding all the way up to 10 times 10 choose 10 whole squared. These brackets are referring to binomial coefficients. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To evaluate a sum that involves a large number of terms, we need to find some sort of symmetry among the terms so to speed up the calculations. This sum involves binomial coefficients, and so to create some sort of symmetry, we need to include all the binomial coefficients of the form 10 choose R. And this R can be either 0, 1, 2, 3, or all the way up to 10, 11 possibilities. So for this sum, we're missing the term involving 10 choose 0. So my first trick is to add a term before our original sum, which is of similar form but includes 10 choose 0. So it's going to be, looking at the pattern, 0 times 10 choose 0 all squared. So now the new sum involves all binomial coefficients of the form 10 choose R. Fortunately, this term is not going to add any extra value to our sum, to our original sum, because 0 times anything is just 0. But we've managed to create some sort of symmetry within the sum. And here comes the second trick, is that I'm going to reverse the so-called coefficients of the binomial coefficients, which I'm referring to these numbers, highlighted in yellow. Since they follow the pattern 0, 1, 2, 3, all the way up to 10, I'm going to add an extra sum, which is reversing the coefficients. For 10 choose 0, I'm going to go for 10 to be the coefficient, and for 1, I'm going to go for 9, and the coefficients start to decrease. 8 times 10 choose 2 whole squared, 7 times 10 choose 3 whole squared, adding all the way up to 0 times 10 choose 10 all squared. And that way, the coefficients of the like terms, say for example, the second column, 1 times 10 choose 1 whole squared and 9 times 10 choose 1 whole squared, have coefficients to be 10 when I add them up. And this will hold for all kinds of like terms among the two sums. So now I'm going to add them up. After adding, I'm going to get 10 times 10 choose 0 whole squared plus 10 times 10 choose 1 whole squared, adding all the way up to 10 times 10 choose 10 whole squared. In this way, I've made the sum to be having the same coefficients among all binomial coefficients. After that, we need to notice a very special property, which is that for the term 10 choose 10 over here, and the term 10 choose 0, we have to notice that they are actually equal. Generally speaking, the number of ways to choose R objects from N objects, N choose R by definition, is N factorial over R factorial times N minus R factorial. And the binomial coefficient n choose a minus r, following the same definition, will be again n factorial over a minus r factorial multiplied by n minus the all a minus r factorial. Simplifying, I will get the same expression. So that means they are equal. Or maybe a combinatorial proof. So these blue squares can be imagined as objects. So now there are 10 of them. Say if I'm going to choose 4 of them, say I choose it like this, the number of ways to choose 4 objects is basically the same as unchoosing the other 6 objects. So the number of ways to choose 4 objects among 10 should be the same as choosing 6 objects among 10. So that's another way to show that n choose r is equal to n choose a minus r. It's basically the same idea. Now back to our sum. So 10 choose 10 is equal to 10 choose 0. And we can do similar things, say on 10 choose 1. On some other term here, the second last term, 1 times 10 choose 9 whole squared. So apart from the binomial coefficient, the coefficient of this coefficient is also equal. So that implies these two bunch of terms actually have equal sum. So when I'm adding things to give 10 times 10 choose 0 whole squared, adding all the way up to 10 times 10 choose 10 whole squared, I'm actually adding two bunches of same values. So which means our original sum is actually exactly one half of the red terms. And the red terms may be written as 10 times the sum of the squares of those binomial coefficients by taking out the common factor 10. And what remains is to evaluate the sum of squares of the binomial coefficients. Using the result that I previously quoted, I'm going to rewrite this as 5 times, but 5 is not part of the result, it's just 10 divided by 2, multiplied by 10 choose 0 times 10 choose 10, because 10 choose 0 is equals to 10 choose 10. Continuing, 10 choose 1 whole square equals to 10 choose 1 times 10 choose 9, adding all the way up to 10 choose 10 times 10 choose 0. The reason that I made the sum longer again is because when the sum reaches this form, I can immediately condense it back to a very short expression. To see this, I'm going to demonstrate visually by considering these 20 objects. I'm going to regroup these 20 objects into these 10 and then the other 10 objects like this. Basically just separated into two groups. So I'm going to choose 10 objects from these 20 red objects. The first way to do this is I just choose 0 among the dark blue group and take all 10 objects from the light blue group. Now the number of ways to do this is exactly equal to 10 choose 0 times 10 choose 10. Also, I could do this again by choosing 1 object from the dark blue group and 9 objects from the light blue group. The number of ways to do this will be exactly 10 choose 1 times 10 choose 9. I can repeat this, not 1, but 2, not 9, but 8, and so on. And at last, I'm going to choose the last way to do this is to choose all 10 objects from the dark blue group, while I'm not choosing anything from the light blue group. And the number of ways to do that will be 10 choose 10 times 10 choose 0. Notice, when I add them all up, it will be a number of ways to choose exactly 10 objects from all these 20 red objects. So the sum of these products of binomial coefficients will be exactly 20 choose 10. Ignoring the tedious calculations, I can tell you that this sum is exactly equal to 9, 2, 3, 7, 8, 0. The original problem from the JEE is actually asking this sum divided by 1430. So the answer to that particular problem in the JEE Advanced Exam will be equal to 646. Just a quick remark before I end this video. In fact, using the similar tricks, I can actually generalize the sum above by replacing 10 by n. So I'm going to use similar tricks, adding a term 0 times n choose 0 whole squared, and this sum actually equals to n times n choose 0 whole squared, because this binomial coefficient is equal to n choose 0, and then n minus 1 times n choose 1 whole squared, adding all the way up to 0 times n choose n whole squared. And these two sums are equal. When I add them together, I'm going to get n times n choose 0 whole squared, n times n choose 1 whole squared, adding all the way up to n times n choose n whole squared. And taking a common factor is equal to n times the sum of squares of the binomial coefficients of the form n choose r. Using a similar way to explain the sum of 10 choose 0 whole squared all the way up to 10 choose 10 whole squared, I can say that the sum of squares will be equal to 2n choose n. So the answer to that generalized sum is n over 2 multiplied by 2n choose n.